as I mentioned, a positively skewed distribution is right skewed and the tail is to the right. A negatively skewed distribution is left skewed and the tail is to the left. You can see here that if a skew has a value greater than -1 or +1, we consider that highly skewed. If it is between -1 and -1/2 or 1/2, +1/2 and +1, then it is moderately skewed. If it's closer to 0, then it's considered symmetric. With kurtosis, that hovers around the 3 or 0. Excess kurtosis of 0 is considered mesokurtic. Platykurtic is that flatter curve, and leptokurtic is the more peaked curve. Here's another representation of skewness. If we start in the middle with the standard normal curve, we treat that like a rope. We pull on the right side of that rope. We're pulling in the positive direction, in the right direction, and we're creating a tail to the right. Typically, the mode will be the highest point of the curve, followed by the median and then the mean. If we pull to the left on the rope, we'll pull in the negative direction. We end up with a left skewed data, and now my mode, median, and mean are going the opposite way. One way to remember that is that they go in alphabetical order or reverse alphabetical order. So when it's left skewed, you have the mean, then the median, then the mode. If you remember in the descriptive statistics portion, we talked about the mean being more sensitive to outliers than the median or the mode. This is a good representation of that. Stem and leaf plot is another way of organizing our data into a picture. The stem portion is the largest single place number. In this case, it would be the tens position, and the leaf portion are the subsequent positions. So for this data set, you can see that we have 3 numbers that start with 1, and those are 12, 14, and 18, represented with the stem being 1, the leaf being 2, 4, and 8. The same thing with the stem being 2. In the 20s, there are 3 observations: 23, 23, and 25. Scatter diagrams are a good way to represent our data when we have direct x's and y's. What we're trying to do is show some sort of relationship which is measured by correlation. So if we have strong positive correlation, we're going to have a very tightly grouped upward sloping line of those data points. Now, with a scatter diagram, we're allowed to have multiple y values for any given x value. Therefore, we do not connect the dots in a scatter diagram. Here we can see a strong negative correlation with the downward sloping trend. And then when there is no trend at all, there really is no slope at all, we have a no correlation. As those data points spread out, our correlation value weakens.